And it's not going to take us a whole heck of a long time to do. It's going to actually go very fast. And so first of all, if you remember from yesterday, we talked about inverse functions. And one of the things about inverse functions is that they were always reflected along what line? What line were they reflected along? Y equals x. Okay, and so if you look at here, when we compose two inverse functions, that's where that y equals x comes into play. Because if I take f of g of x, I am going to get x for every x in the domain. So if I compose those two functions, same way if I compose them the other way, if I take g of f of x, I will get x as well. And so that's how we can show that two functions are inverse functions. And so what we're going to go ahead and do is we're going to go ahead and look at the following. Okay, it says show that f of x and g of x are inverse functions. And so in order to do this, we're going to use that little bit of information that was just on the previous slide. Okay, and so what we're going to do is we're going to actually find f of g of x. And we're going to show that it equals x. So if you remember from when we did this a few days ago, okay, what's the first thing I do here? Yep, plug in g of x. So I'm going to replace the parentheses. Oops, sorry. I'm going to replace g of x right here. So really I get f of 6 over x plus 4. Now what I'm going to do is I'm going to take this whole thing right here, and I'm going to plug this in where? Into the f of x. So I'm going to plug it right there for x. So this is where things get kind of a little messy for just a little bit. So I've got 6 divided by 6 over x plus 4, and then minus 4. Yes, your 4's cancel, as you've already noticed. Those are gone. So really, I now have 6 divided by 6 over x. Well, how do you divide fractions? You multiply by what? The reciprocal. And what's the reciprocal here going to be? X over 6. So what ends up happening? Your 6's do what? Cancel. So, and I've got x. So I've showed that f of g of x equals x. That's one. Now I've got to show the reverse. Okay, so now instead of f of g of x, I need to show that g of f of x. And so these are kind of like proofs, because you obviously know that you need to get to x, right? I mean, and it's just a matter of kind of manipulating until you get there. So I'm going to replace f of x with what? Right. And so what I'm going to do then is I'm going to go ahead and take this, and I'm going to place it right here. So really I have 6 over x minus 4, and then plus 4. And like I said, things get messy, but you saw in the previous one that they kind of clean up really well. So I'm going to write this as 6 divided by 6 over x minus 4. And then plus x, or plus 4. Not yet. Okay. So on that previous slide, how did we do that? 6 times So then notice what ends up happening. Your 6's cancel. And it leaves you with x minus 4 plus 4. So what happens to your minus 4 and plus 4? And it leaves you with x, which is exactly what you wanted. Okay. Now, if you don't get it to work to equal x, you've done something wrong. Or they are not inverse functions. So let's go ahead and look at the next slide. Use the graph to graph the inverse graphically. Now I'm going to tell you this one's like the easiest problem we've done. Because if you remember, when we looked back at those tables of the graphs, remember? Okay. What did we know about the inverse functions when we dealt with tables? What did the x and the y do if they were inverses? They flip-flopped. So in this case, what are the coordinates of this point right here? 0, 1. So on the inverse, it's going to be located at the point 1, 0. So I'm going to come here and put a dot right here, 1, 0. All right, let's pick another point. I see we've got this one. What are the coordinates of this point? Negative 1, 0. So where would the new point be at? 0, negative 1. You see how I'm doing that? I'm just flipping. Okay. Where would be another point that it looks like it goes through? Right here maybe? And that's 1, 2. So where would the point be at? 2, 1. So what's going to end up happening? And you're probably wondering, well, good grief, how do we draw this in? It's a good question. Okay. Remember, it's reflected over the y equals x. So do you see how that kind of worked? Y equals x is the diagonal right here. Okay, y equals x is that diagonal. And so what I do is I imagine that there's a mirror there. Okay, and so that's kind of why I drew, this curve here and then this curve here. Because there's like a mirror right in between. Okay, so you should have enough now to finish the rest of your assignment. Okay, we're looking at your test probably Friday, Monday. Okay, so anyway, sorry, it's kind of where it's going to fall.